Let's start this module by talking about Syslog and its value. So what Syslog is doing here for us is it's a mechanism for a router or any other networked device, whether it be a router, switch, PC, server, doesn't matter what it is on our network. Syslog is a mechanism for us to transfer the log message that occurs on a device to a central server. And the way we do that is we implement a Syslog client, like a router, and a Syslog server. And the Syslog server is nothing more than a device on our network that is running a Syslog service. What happens then is, should an event occur on the router, link goes down. What happens then is that creates a log message on the router. Sometimes we even see these log messages happen while we're configuring the router. When you enter that no shutdown command on an interface, it changes the interface from an administratively down state to either down or up. And when that state change happens, we generate a log message. You've probably been noticing this as you configure the router, that you're constantly getting interrupted with these log messages. Well, these log messages are something that we can actually send to our centralized server so that we can maintain a database of log messages over a period of time. That way we can use that information in Syslog to go back and troubleshoot issues that happened in the past, and or do some investigation of network security issues that happened on our network. So when this event occurs, link goes down, what happens is we generate that message on the router. If our router is configured to send our messages to the Syslog server, what it will do then is it'll take that link down message, forward it to the Syslog server. The Syslog server will then store that in its database. Then when another event happens, link goes up, right? Link is no longer down. Whatever event happened, it resolved itself. So we get another log message saying fast Ethernet 01, change state to up. Then we forward that to the Syslog server. The Syslog server is nothing more than a collector of data. It does not ever respond to the client saying, yep, I got your message. Doesn't ever do that. So we're using UDP here to send these messages. And all that's happening is the client sends a message to the server, and then the conversation is over. If it happens that the server does not get the message, well, that's how this protocol works. It's best effort. If we miss some log messages, our network, chances are, will not break if we miss log messages. It's just very convenient to have those log messages in the future. So our Syslog server is going to keep a database of all of the messages that came in. In the case that I was showing you here, we only had one device that was sending those log messages. When we have multiple devices sending log messages, the Syslog server is going to keep track of which device sent that message. So we'll not only know what device sent the message, we'll know what time the event happened and what the event was. So Syslog is this incredibly valuable protocol that allows us to do troubleshooting both immediately while events are happening, as well as troubleshooting in the past. I've actually used a Syslog server in the past to discover some nefarious behavior of users on a network in a past career that I've had. We used those syslogs that we collected to find out that a user was actually doing some pretty ugly and nefarious stuff on the workstations on company time, and we were able to collect that information and use it to give to HR to help mitigate that particular issue. So Syslog servers can not only help you with technical stuff, but they can also help you discover other nefarious things that are happening on the network. One of the issues that can happen, though, with Syslog is that if the time is not configured correctly on our devices, the Syslog server is going to receive messages, and there's going to be a timestamp on that message from the device that may or may not be correct. So here, the actual time is October 7th at 7:56 p.m., and let's say all three of our routers have links that go down all at the same exact time. We forwarded all those messages to the Syslog server, and when we look at those messages on the Syslog server, what we know is that A, B, and C all had that up-down happen at the same exact time, at 7:56 p.m. on October 7th. If we look in the list here, though, looks like router A sent that at the correct time, but router B's date is set to October 5th at 1:44, And router C's time is set to January 1st, 10:15 p.m. So even though all three of these devices had the same event happen at the same exact time, and they all properly sent their messages to the Syslog server, the Syslog server recorded those times as distinct and unique because the routers that sent them all had different timestamps configured. Since these events all happened at the same time, but they were recorded as happening at different times, this can actually make troubleshooting a little more complex and actually make troubleshooting worse on our network. So what we want to do is we want to find a way to get all of our devices to have the correct time listed on them.